If you want to try this one on your own, go ahead and pause the video, but I'm going to go through it in 3, 2, 1. I'm given a certain criteria about x in this problem. I was told here that x has to be greater than 5, and we are trying to find the value of y. So let me go ahead and try and separate the x's from all the y's to see if I can focus on just the x's and just the y's separately. First, I will focus on the 2x squared plus x squared y. They both have a common factor of x squared, so I'll pull out the x squared, leaving me with 2 plus y. In the next two terms, I have a negative 2xy and a negative 4x. Between these two, I see that there is in common a negative 2x. When I factor out that negative 2x, I'm left with a positive y and a positive 2. Then my final two terms here, I'll go ahead and factor out the GCF from here as well, which would be a negative 15, leaving me with a positive y plus 2. And all of this equals 0. Now this is great because notice that each of these pieces has a factor of y plus 2. This first one is in a different order, but the sum of 2 and y is also y plus 2. So I could then factor that y plus 2 all the way out to the front, leaving me with x squared minus 2x minus 15, and I have successfully separated all of my x's and my y's. Let me go ahead and keep factoring this quadratic. I need two numbers that have a product of negative 15 and a sum of negative 2. Those numbers are 3 and negative 5. And because my leading coefficient is a 1, I can factor this into just x plus 3, x minus 5. I have that y plus 2 in the beginning, and it all equals 0. I'll go back to my conditions up top. I was told that x is greater than 5. If this whole thing equals 0, one of the factors must be 0. If x is greater than 5, then this factor will not be 0. I would need x to be negative 3 in order to get that factor to be 0, and negative 3 is not bigger than 5. Here in my third factor, x would need to be 5, but my condition is that x has to be strictly greater than 5. So that third factor will never be 0 either. So we're not going to get a solution from either of those factors, meaning the only possible place where we will get a solution for this equation is this factor of y plus 2. This has to equal 0 in order to be able to apply the zero product property and end up with a product of 0, which means that y has to equal negative 2. And that is it.